Thank you for tuning in to This Automation Life, brought to you by Brenner-Fiedler. I'm your host, Jeremy Schubert. Each week we discuss technologies used in automation. This week, Jonathan Ludlow, Business Development Manager for Microscan, is here to discuss verification and its merits in printing. Thanks for joining us today, Jonathan.
Well, thank you very much, Jeremy. Glad to be here.
So, Jonathan, when we talk about verification and printing, I guess give me a little more insight. What are we talking about with verification, and I guess how it applies to printing?
Well, usually we apply verification to as a check on the quality, and that might mean the future readability of 1D and 2D barcodes. Everyone, I think, is familiar with one-dimensional barcodes, the familiar UPCs you see on various products. It's very important that these can be read all the way through the supply chain right up to the point of sale. So verification is the process where we essentially check the future readability of the code. Sometimes it's referred to as grading, but
Okay.
proper term is verification.
Okay, so I think everybody can picture a UPC on a can of green beans or whatever it may be. And then a 2D code, that's similar to like the QR codes that are on advertisements a lot these days, correct?
That's correct. QR code is very much in the public eye. In industrial applications and in other places in commerce, there's something called the data matrix, which is very similar to QR code, but doesn't have the big squares in the corners.
Okay, gotcha. Okay, so if we're talking about verification, and especially if our topic is merits, what are the merits? Why would you want to read this thing? Can't you just assume that, all right, I printed this thing or I applied this label, we're good?
Well, many people do. And what they find out is that further down the chain, maybe in their manufacturing process where they need to read and identify the product, they find it can't be read. And imagine this causes a lot of inefficiency. Also, further down the supply chain, they may be supplying product to a customer, a Target or a Walmart or somebody like that, who in fact insists that the code reads correctly at the point of sale or when it gets to the warehouse, and might even be fining their customers, fining their vendors if they don't supply codes that are above a minimum grade.
Yikes. So there's some direct financial impact when it comes to verifying a code to prevent a fine. And then there's kind of the soft financial impact of there's potential process difficulties from having a non-verified code. Am I hearing that right?
That's a very good summary. And as time goes by, more and more manufacturing and other business processes really depend completely on the ability to identify product and track it through manufacturing processes, even down to the point where each component might have a unique identity, and you need to establish this identity to match them with other matching components.
Okay. So this is not just saying that a component is a widget for sale, but that's this subcomponent of a widget, and that goes with these three other subcomponents while you're assembling.
That's a very good illustration. For instance, when you manufacture internal combustion engines, they run much smoother if all of the pistons are the same weight, and that's how if you weigh and identify each piston, then you can match them. And
Wow.
this is an application of direct part marking. You give it an identity by putting on one of these data matrices, maybe stamping or laser marking it, and now it has its social security number.
I see. Okay. That's that's very cool. So I think that there's clear benefits to verifying, but let's talk about why do we actually need to verify? What could cause these labels to go wrong or printing to go wrong?
Well, there's all sorts of things that can go wrong in a printing process. The ink can spread too much. A laser mark, the laser can be out of calibration.
Hmm.
If you're printing with an inkjet, you could have some of the jets blocked, And usually there's no way, just by looking at the code with the naked eye, to tell whether it's going to be read or not.
Okay. Okay, so I want to touch on something else that you mentioned that goes into that. You and I can't look at a code and well, maybe you can, but and know that it's a good one. But you talked about a grade. So
Well, classically, the standards, there's ISO standards for the quality of 1D barcodes and 2D barcodes. In fact, the standards are written such that a grade of 1 is almost perfect, and a grade of 4 is a very low grade,
okay,
and 0 is a fail. Now, for some reason, everybody translates these into letter grades and refers to them as an A for a really good grade and a D for a poor marginal grade.
okay, gotcha. So realistically, verification could be as simple as just making sure it's there, and it could go as high end as verifying that it meets an ISO standard above a certain threshold.
Yes, now a lot of people will tell you that they verify the code that they've made just after they've marked it or printed it, and what they're telling you is that they run it through a reader, and if it reads, they give it the thumbs up. To my mind,
Hmm.
this isn't really grading. This is a sort of no-go, no-go measurement, and
Okay.
the code could be just on the, right on the hairy edge of readability at that point, and you'd never know.
Yeah, or
That
maybe you're using a really good reader to check it, and then later you're using a reader that's not so good and it doesn't read.
that's absolutely the point. So you
Oh,
need to actually make a measurement of the quality rather than just do a go no go measurement.
very interesting. Okay, so we've got some good reasons why you want to verify and why you need to verify. So let's talk about how can somebody do that? How do they check it?
The up to classically, there's been systems which usually consist of a camera or a handheld scanner, um, which make the measurements specified in the ISO standard, and this is typically done offline.
Okay.
Um, but now it is becoming possible by using essentially machine vision systems to do this measurement inline, so that
Oh,
you can
interesting.
check every part as it is marked before it moves off through the manufacturing or um, chain to the in commerce.
Okay. So the old system, it sounds like, was take a sample, a random sample, and you can do statistics and make sure that based on that random sampling, you're good. And and now there's the ability to check 100%.
That is correct, and in fact, if the system's set up properly, you can detect that the marking system is beginning to go out of tune, if you
Oh,
like, before it actually creates bad marks. So you're doing simple process control, if you like, on the marking process and catching problems before they happen rather than when it's too late.
that's very cool. So you get the opportunity to maybe do preventative maintenance on your read writer, or whatever it may be, your writer, I guess. Uh,
That's absolutely correct.
cool. Okay, so if it's a vision system that's doing this in line, I guess are there specific vision systems for doing verification, or this is integrated with one they may also be able to do inspection or
Well,
part location?
yes, that is typically the case. And in fact, it's also there's possibility that to do checking on the human readable text at the same time as you're verifying the quality or the penmanship, if you like, of the 1D and 2D codes. The standards are very specific about how the camera should be positioned and how the part should be lit. Whilst doing the verification. So those conditions have to be observed if you want to create if you want to grade the parts according to the standards and be able to put your hand on your heart and say they get ISO standard grades.
Gotcha. And so that is that available as a package, or does somebody have to piece out? Here's the vision. I got to read this standard and interpret. Here's the lighting, that kind of thing. Or are there like standard off the shelf kind of things where they
Uh,
can set this up?
there, there's not very many readily. shall we say, pre-configured systems for inline verification. There are some for offline verification.
Okay.
As an example, I can say that Microscan has created what we call some of our verification kits for which consisting of the camera and the light mounted in the appropriate geometry
Okay.
to facilitate this kind of thing.
Okay. Interesting. Okay. So it exists, but it isn't so common. Okay. Very cool. Well, I guess given that, you know, we're getting close to the end of the time. Is there anything else that you might want to mention about, how to accomplish this, or any tricks, keys, tips that for our listeners out there?
Well, I would say that don't be afraid of it. When you read the specifications, it sounds complicated, but it isn't that difficult to implement. And I would also say that you mustn't be dazzled by the requirements of the standards, especially if you are implementing verification to support in-house processes. There you can do it a little less rigorously if your goal is to make sure that the mark or code can be read during the manufacturing process, and your concern isn't to support requirements of your customer, for instance.
That's a good point. You may not need to hit this exact ISO requirement to make sure that process B can read what process A did. Okay.
Absolutely correct.
That'll save some people from choking on a
Yep.
lot of difficulty there. Okay. Well, cool. Well, that's all the time we have this week. Jonathan, thanks so much for joining us.
Entirely my pleasure.
And thank all of you for listening to Brenner-Fiedler's This Automation Life. If you have questions about what you've just heard, or if you have a topic you'd like to hear discussed, please email us at tech@brfa.com. That's TECH@brfa.com. And be sure to continue tuning in each week as we continue to elaborate and explain the world of automation.